Welcome to our channel. In this session, we will move to the concept of generate and test in artificial intelligence. What is mean by generate and test? The main approach of generate and test is simply it needs to search the state space for finding out a solution. You know the concept of state space. Simply, a state space search explore all the nodes to find out the solution. And the generate and test is also used to search the state space for the solution. Now, any search algorithm mainly two components. The first one is for the given problem, it generates a candidate from the state space. What is mean by candidate? Candidate in the sense one feasible solution or one solution. And the second step is test whether the generated candidate is the perfect solution or not. Now, got the point? Understand the algorithm carefully. The algorithm for the given problem, we have multiple number of solutions are available. That means while more candidate exist, here observe more candidates in the sense if more number of solutions are generated. Now, what is the first step? Within that, take the first solution and check whether it is a solution. That is, whether this is the best solution or not. If it is the best solution, okay. Otherwise, repeat the entire process. Take the second solution, test whether this is the best solution. Means whatever the best solution we assumed, that is compared with remaining all the solutions. You got the point? Generation of multiple solutions and check each and every solution, which one is the better one. That is called generate and test strategy. Clear the point? Now, in this generate and test strategy, suppose if you have a problem domain, means how do you produce the solution? How do you check whether the solution is the best solution or not? So for that, we are using two different functions. Here, these are same only. The two different functions. The first one is move gen of state. The function is move gen, means here whatever we are providing, this is the input state. For example, assume these are my data points. Like this, my data points are available. Assume this is the my current input state. Now, what the move gen do? Simply takes this state as the input and return the set of states that are reachable in one step. See, only this, the set of states that are reachable in one step, all the set of states are generated. Simply, the moveGen function generates the successors or children of the input state. This is the use of this one. That means exploring all the states. Suppose from this, I am moving to this one. Again, if this is the current input, the move generation move to their successor like this. Now, goal test of state. Goal test of state means it returns true when if the input state is the goal state. Here, this is input state. Assume if the input state, whatever you are providing, if that is equal to the goal state, it returns true. Otherwise, it returns false. In some variation of this function with two parameters. Here, what is this one? Here also, the input state is compared with the explicit goal state. You understand the difference between second one and third one? In the second one, here the goal is described with some properties and these are checked by the function. But in the third one, we are explicitly past the goal state. Our input state is compared with goal state. Input is compared with goal state. You got the point? These are the main functions that are used in that are used in generate and test. Now, where we are using this generate and test, if you want to solve word puzzles, And if you want to try all possible password combinations, I think you understand the internal meanings. All possible. That, for example, my password consists of the letters A, B, C, D. By using these letters, I am generating approximately, assume 4 factorial combinations. That means my first password is some A, B, C, D. This is one solution. Check whether this is the correct password or not. Suppose ACBD, suppose ABDC. Like this, different passwords are generated. Clear the point? Clear? Now, for this generate and test, we will move in detail by considering one popular example, man, lion, goat, cabbage problem. I think everyone know the problem. What is the problem? We have a man M. The aim is the man needs to transport a lion, goat, and cabbage across a river. That means the man take all these and cross the river. That is his aim. By using some boat B. By using some boat B. And one more condition is, along with the man, at a time he can take only one of them. That is man and lion, or man and goat, or man and cabbage. Only one element or one item or one entity is taken by the man. And one more thing, if the man presence is there, nothing is happened. Suppose if the man presence is not there, simply lion eats the goat. If these are available, lion eats the goat or goat eats the cabbage. That means, while for example, if the man takes the lion and crosses the river. Here left to side G and C are available. That means the goat is the cabbage. This is not at all possible. This is possible. Your aim is you need to avoid such type of situations. Now you understand what is the problem? I think clear. Now, how do you implement this one? By using generate and test. For this state representation, we are using two lists. For the basic approach, we are using two list for representation. This is the start state, this is list 1, and this is list 2. In the start state, manu, goat, lion, cabbage, and boat are on the left side. That is left list, and the right is empty. And obviously, what is the goal state? The left to river is empty. All the entities on the right side. All the entities on the right side. Clear the point? This is. Now, what happened? By using that moveGen function, we are generating all the possible moves. Once the generation of possible moves, removing illegal. See this one? Suppose Manu, go to lion, cabbage, and boch. Now, what are the one possible moves? For example, the left to a man, only man crosses the river. Anyway, man is there, obviously boat is available. Only man crosses the river. In this, what happened? Either goat is the cabbage or lion is the goat. This is illegal move. Suppose here, man and lion crosses the river. Here, goat and cabbage are available. This is illegal. Now, man, cabbage crosses the river. Lion is the goat. This is illegal. Here, man and goat crosses the river. Lion is not eating the cabbage. So, this is a legal move. So, in the second state, we are considering this one. I think you got the point. This is the way generate all the possible moves. Among them, filter out the illegal moves. Okay, this is the basic. But if you observe carefully, here what happened? We are transferring the elements from left to right. Again, the man moves from right to left, right to left. That is moving from left to right and right to left. That is transferring the elements in opposite directions. Yes or no? And at the same time, some information is repeated. And because of that, to avoid such redundant information, to avoid such type of opposite directions, instead of maintaining two lists, it reduces to one list. In the list, left to specify. The boat is on the left side. Right specify. The boat is on the right side. You got the point? By using that one only, we implement this one. Now, finally, how the moveGen function is implemented. So I said the moveGen function is implemented. How? First step, initialize. Observe the steps carefully. Initialize set of successors. C to empty set means we are going to build a list of all possible next moves. That is all the successor states. N is my input state. From this input state, you need to identify all the successor states. Initially, I start from an empty list. Initially, the list does not consist of any element. So, initially, C is equal to empty. Okay. Now, next step, add M. M is man. Add M to the complement of given state N to get a new state S. First of all, what is mean by complement? That is the most important. What is mean by complement? For example, N, assume we have a set M, L, G, C. Now, what is the complement? If this is the full state, assume if N consists of M comma L. If N consists of N comma L, now the complement is G comma C. I think you understand the meaning. Whatever that are available in, except that those are available in complement. Now, what is the second step? Second step is add M to the complement of given state N to get a new state S. So initially all the elements, that is all the possible entities, this is one set. If N is my current state, understand carefully, N is the current state. Okay, and initially where they are available, all are available on the left bank. All are available on the left blank. Now, the complement of N means the entities that are placed on the other side, that is right side. Now, adding M to the opposite direction, that is the M. Now, simply what is the state? S is equal to complement of N plus M. Now, complement of N, initially all are available. Complement of N is empty. Initially only M is available. Clear? Clear? That is M is on the right side. Suppose if the given state has left, then add right to S. Otherwise, add left to S. What is the meaning of this one? Suppose if the current state N, if your current state N includes left, if your current state N includes left, means the boat is on the left side. Obviously, what happened? The boat is on the left side, then move the boat to the right side. So here you need to update the state by adding the right. That means S is equal to right. For the S, we are appending right. Exactly. Suppose if you are on the right side, if the current state is on the right side, then boat moves to left side. For the state, you are adding left. To clear the point? That means if the given state is on the left, then move to opposite direction. Otherwise, that is right direction. If it is on the right, move to left direction. Now, after moving, if it is legal, legal in the sense, you know that one. It is a valid state. If it is a valid state, then add to that legal. Otherwise, ignore that one. If it is not valid, ignore that one. Observe the point carefully. According to this example, first this is generated. This is illegal. Next this one is generated. This is the valid state. This is valid state. Now the remaining. For all the remaining entities, what you need to do? Make a copy. Suppose S dash is equal to S. Whatever available in S that are placed in S dash, Now add that entity. For example, what is the entity you are taking? Suppose M. M only move. Initially, I am moving. Suppose M comma goat. In the next step, M only moves in the reverse direction. If placing this M in the S dash, if it is again legal, then add. The same process is repeated. I think you got the point. So this is the way how do we generate, how do we implement, generate and test algorithm. That is the end of the session. Thank you.